Okay, Chem 20, so hopefully those problems were okay, or at least a few of those problems were okay. Let any of the chemistry teachers know if you have any questions about it. We're going to move on to something called stoichiometry. Now, stoichiometry is a really big fancy word, but all it means is being able to predict the amount of a substance reacted or created from another substance. So, it's using the molar ratio to predict how much of a substance is produced or reacted. Using the molar ratio. You know, you don't know what that is, and that's totally fine. We're going to talk about what a molar ratio is here in a second. The best way that I can tell you what stoichiometry is just by doing an example. So we're going to dive right into an example of a question. So, how many moles of oxygen will be created when 10 moles of water are decomposed? I'll give you a second to write that question down, or pause the video if you need a little bit of time. How many moles of oxygen will be created when 10 moles of water are decomposed? Now, this question is a very stereotypical, kind of simple stoichiometry question. And when I say simple, I mean like one of the easier versions of stoichiometry, because we're just learning about it right now. You know this is a stoichiometry question because it asks you about one substance while giving you the information from another substance. So it says, how many moles of oxygen, but then it says, if 10 moles of water are decomposed. It's giving you information about two separate substances, and that's how you know this is a stoichiometry problem. The way we're going to solve this is by writing a balanced chemical reaction, that's step number 1, and then using unit analysis along with the molar ratio. So let's write step number 1, a balanced chemical reaction. That's what we have to do, okay? So step number 1 is a balanced reaction. So we're taking water and we're decomposing it. Okay, no problem. We're going to take water and we're going to decompose it into its elements. Water is going to decompose into hydrogen and oxygen. Now, hydrogen is an element, so we have to follow the Hofbrinkel rule. H2 gas. And then oxygen is also an element, so we have to follow Hofbrinkel, okay, O, so O2 gas. Now we need a balanced chemical reaction, so let's go ahead and balance this. 2 hydrogens, that's great. 1 oxygen in the reactants, 2 oxygens in the products, that's not so great. So I have to put a 2 in front of the water. And then that means I need 2 times 2 is 4 hydrogens, so I need 2 times 2 is 4 hydrogens. Now, I don't know if you know what these coefficients actually mean. So right now, water has a coefficient of 2. What does that 2 actually mean? Hydrogen has a coefficient of 2, oxygen has a coefficient of 1. What this coefficient of 2 means is it means 2 moles of water. Whereas the 2 in front of the hydrogen means 2 moles of hydrogen. And by writing no number in front of the oxygen, we really mean 1 mole of oxygen. 1 mole of oxygen. So this chemical reaction is telling us if we had 2 moles of water, then we could make 2 moles of hydrogen and 1 mole of oxygen in this chemical reaction. Now, it's in any stoichiometry problem, what I suggest you do is I suggest you put the information from the question below who it belongs to, including the information that you're looking for. So let's go ahead and do that right now. It says, how many moles of oxygen will be made? Great. So I'm going to put mole question mark under the oxygen. That's what we're trying to find. We're trying to find the moles of oxygen. Okay, no problem. When 10 moles of water, so under water, I'm going to put 10 moles under the water. This is another way, this is another reason why you know this is a stereotypical stoichiometry problem. It's giving you information about one thing and then it's asking you information about another. So this is stoichiometry. Now, because it's stoichiometry, we need to use a molar ratio. We haven't talked about a molar ratio yet, but the molar ratio is the ratio between the coefficients of the unknown substance, the thing with the question mark, and the known substance, the substance you're being given information about. So the molar ratio is always unknown over given. So unknown over given. It's going to be the thing with the question mark, so that coefficient, which is one mole, and I'll move my calculator over to the other side here. 1 mole. One mole of oxygen for every 2 moles of water. What we're doing is we're setting up a ratio between the 2 pieces of information that we're being given. We have to use the coefficients from the balanced chemical reaction. Now we have everything that we need in order to do some stoichiometry. We have the information from the question, and we have the molar ratio. Let's do some stoichiometry. That means unit analysis. So, in unit analysis, you always ask yourself, or you always tell yourself what you're looking for. It's saying, how many moles of oxygen, right? And you kind of told that to yourself. So, write moles of oxygen. The reason why we didn't just say moles instead of moles of oxygen is because in a stoichiometry problem, there's 2 different substances that we're thinking about. And so moles, we could mean moles of oxygen, or it could mean moles of water. So in a stoichiometry problem, you really want to label not just the number and the unit now, but you want to label who the unit belongs to. So moles of oxygen. In order to find moles of oxygen, we need to check out our information here. Find something that has moles of oxygen in it. Take a look at the molar ratio. It's got moles of oxygen in it. So that's what I'm going to use. 1 mole of oxygen for every 2 moles of water. Good. We have the unit that we want, moles of oxygen. We have that unit, moles of oxygen on top. Now our goal is to cancel out moles of water on the bottom. So I'm going to multiply by the piece of information that we're being given. 10 moles So not only am I writing a number and a unit now, but I want to write who the unit belongs to. So 10 moles of water. So here, moles of water and moles of water can cancel each other out. And when you put this into your calculator or do the math in your head, right? So 1 times 10, 10. 10 divided by 2 is 5. So we're going to get 5.0, rounding to 2 significant digits, 5.0 moles of oxygen. Now that could have been pretty easy for a lot of people if they just looked at it. You know, all you got to do is look at it to try and kind of figure it out. But using the molar ratio is helpful. Following this set of steps is going to be really helpful for us. So number 1 was write a balanced chemical reaction. Number 2 was using unit analysis using the molar ratio. We're going to go ahead and we're going to do another example here, and then I'm going to let you do some practice, and we're going to build on the stoichiometry a little bit more tomorrow. So let's do another example. Iron can react with oxygen in a formation reaction. How many moles of iron are required to react with 0.36 moles of oxygen? Give you a second to write that down. Iron can react with oxygen in a formation reaction. How many moles of iron are required to react with 0.36 moles of oxygen? Okay. How do we know that this is a stoichiometry problem? We know this is a stoichiometry problem because it's giving us information about one substance, moles of oxygen, and then it's asking us about a different substance, how many moles of iron. So we need to write a balanced chemical reaction because we need the coefficients in the chemical reaction to make a molar ratio. Let's go ahead and let's react iron and oxygen together. So iron is an element, but it's not part of Hofbrinkel, so it's just Fe. Plus oxygen, sure, O2. They're going to react together and they're going to make an ionic compound. The iron and the oxygen are going to form ions, so we have to figure out what combination of ions we need. Well, what version of iron, what's the charge on the iron going to be? We go ahead and we take a look at iron in our periodic table. Iron, when it turns into an ion, the most likely ion charge that will form is +3. So iron is going to be iron 3. And I'll just write that kind of off to the side here. And then when we look at our periodic table again, for oxygen, oxygen is going to form a -2, right? -1, -2 ion. So oxide is going to be O with a 2- charge. So 3+ and 2- means we're going to have a formula of Fe2O3. So iron 3 oxide, and it's ionic, so it's going to be a solid at room temperature. Now let's go ahead and balance this. We needed a balanced chemical reaction. We always look at the most complicated substance first, and then deal with the simplest substance at the end. So let's deal with the oxygens. 3 oxygens, 2 oxygens. So we got to go 3 and 2. Now we have 2 times 2 is 4 irons. So I got to put a 4 in front of the iron. That's step number 1. That's our balanced chemical reaction. Now we have to do step number 2, which is unit analysis, including the molar ratio. So let's look through here. Take a look at your question and put the information below the substances that you're thinking about. How many moles of iron? So I'm going to put moles, question mark, under the iron, are required to react with 0.36 moles of oxygen. 0.36 moles of oxygen. Now, the only way to convert between these two substances is using the molar ratio. The molar ratio in this case, so unknown over given, right? Use the coefficient of the unknown substance over the coefficient of your known substance, the information you know stuff about. So 4 moles of iron over 3 moles of oxygen. Now we have all the information that we need in order to do our unit analysis. So when we do our unit analysis, this is kind of step number 2, you always tell yourself what you're looking for. What are we looking for? Moles of iron. So moles of iron. In stoichiometry, you have to say what unit you're looking for and who it belongs to. Okay, no problem. So I take a look and I'm trying to look for moles of iron somewhere. I'm literally going to take this information and use it as like puzzle pieces, right? So 4 moles of iron, okay, that's great. Now I have my information. Then I can cancel out moles of oxygen using the other information. So 4 moles of iron for every 3 moles of oxygen. Good, I have the unit that I want now. That's what unit analysis is all about, is finding the unit that you want and getting rid of everything else. I have moles of iron, let's get rid of moles of oxygen. Look under oxygen and find moles. 0.36 moles of oxygen. Over 1, sure. Moles of O2 and moles of O2 cancel. So now we can get 4 times this divided by that on our calculator. So 4 times 0.36 divided by 3 is going to be 0.48 moles of iron. And we already have 2 significant digits. So I think I've stolen enough of your time today. I want you to do a little bit of practice. Again, kind of like 10 minutes of practice on this. Just get what you can get done. And this is a good introduction for tomorrow. We're going to take this a step further tomorrow. So let me know if you have any questions. Let any of the other chemistry teachers know if you have any questions. But the most important part of this, balanced chemical reaction, and then find the molar ratio between the 2 things that they're talking about in the question. Okay? Have fun.